Hello, good morning, everyone. Well, my name is Lorenzo Pastrana. I came from Portugal. I am Spanish, but right now I am working in Portugal. Let me just to show a small video. We are located here in the north of Portugal, very close to the Spanish border, and this is a very brand new institution. So we are the only institution in the world devoted to nanotechnology, to do research and technology and innovation devoted in nanotechnology. So we have a very nice facilities and state-of-the-art in terms of microscopy, like the Instituto de Nanociencias de Aragón or other places. But the most important thing that our approach is to integrate different expertise, different solutions, in order to provide integrated solutions for problems that are or have the industry. So we cover from the electronics to the health, from the environment to the energy, food, materials, quantum materials, etc. So we have a very special legal status, so we are international. That means that right now the member states are Spain and Portugal, but we are open to include other member states, and we operate around the world. So we have representatives in Israel, we have representatives in Hong Kong, in Shanghai, in the Boston area, in the States, in the West Coast as well. So this is just a very brief overview of my institution. So I don't know if everyone is aware about nanotechnology, or for someone nanotechnology is something. Are you familiar with nanotechnology? Everyone? Okay. The point is the sailors, during the old sailors, when they approach to zones or areas that are unknown for them, so they say here there are dragons. So meaning that it's not, they are not very aware, no, how to explore these areas. So in the world, we have a problem, which is the growth population, and it's estimated that the 70% of the food will be from new technologies in the next future. And that means new technologies that not exist right now, still. No? So we have to develop new technologies in order to provide this big problem or this trend in the population. And the future foods will be healthier, safer, sustainable, tastier, and how to harmonize all these characteristics is my aim today, this morning, no? To show how nanotechnology can harmonize all of these characteristics. So just to explain why, if someone is not aware about nanotechnology, why size matters. So if you see one sugar cube of 1 centimeter size, so the surface is 6 square centimeters for 1 cubic centimeter of volume. If we split this in small cubes of 1 millimeter each for the same volume, we have much more, 10 times more surface. But if we split this in 1 nanometer, we have this surface that is equivalent at several football fields, so for the same volume. So that means that the relationship between surface and volume is a very important thing, because the number of atoms in the surface rise a very high proportion when the size is very small. And these atoms are the atoms that react in the reactions, and that explains why at this nanoscale the properties are quite different, because the number of atoms that are able to react in the surface are really, really important in relation with the whole of atoms in the materials. So taking advantage of this, the first thing that I would like to show and to share with you is to make a trust with nanotechnology. I would like to present the most famous nanotech factory, which is this other count. So this is really, really a very important nanotechnology factory that produce this nanotech beverage, which is called milk. And depending how we make, we obtain different structures combining the ingredients, so proteins, caseins, alpha-lactalbumin, beta-lactoglobulin, lipid micelles, we can obtain different products with very different properties. It's not the same one cheese than one yogurt, and that depends on only how these ingredients are structured at this micro and nano scale. So, and this is so the first message is we have to be aware about nanotechnology. Nanotechnology is in the daily base in our houses every day. So, and it's natural, it's something no artificial. So, we need to provide trust to the customers. So, we are eating every day nanotechnology. Well, regarding healthier foods, I would like to show some examples that the kind of things that we are doing in my lab during these years. One problem is one trend is the personalization. Personalization is very important in the future of the food system because the needs of a baby is not the same that a pregnant woman, or the same needs of an elderly man. For example, my father. This is my father, by the way. So they have different needs, and the industry have to provide foods adapted for these needs. So one way, and in the case of elderly, by the way, it's a very important trend because look at this. So Spain, Portugal, and China, 1 out of 3 people in 2030 will be over 60 years old. So that means a high pressure with the security social system, the health system, to support the problems associated with this elderly population. And food play a very important role in the personalization of these people to promote healthier foods. One of the problems is the hypertension and diabetes. So this is the figures regarding diabetes in the world. So it's really a very important problem. And it's a problem that is related mainly with elderly people. Well, how nanotechnology can help for that? We develop a system to obtain nanosalt. So it's just to create very small salt grains by using nanotechnology in order to salt, for example, chips, almonds, or peanuts, or whatever. So the aim is reducing the size of the salt. We are able to produce, to have the same salty sensation in the tongue. So in the mouth, we have the same salty sensation, but the intake of the salt is just a half of the salt that usually you eating these chips and these regular salted products. So it's a very simple way to change the mindset, how to use nanotechnology to obtain, to take advantage of this reducing size. No? That was a trial that we did in Sweden. So with regular salted almonds and nano-salted almonds. And the people in this trial was not able to, the Swedish people, and I think that the Spanish or Greek or Israeli people will be the same, no? The same behavior. So we're not able to distinguish between the regular salted almonds with the nano-salted almonds. And the amount of salt was exactly a half of the regular salted almonds. So it's a way to explain that. Another problem related with personalization and elderlies is a very common problem, which is dysphagia. Dysphagia means that usually elderlies have to eat very soft or meals. So, but the problem is how to convert ingredients that usually are soluble in ingredients that could be or could have these particular rheological properties for elderlies. One way is, for example, by 3D printing machines. So we use these 3D printing machines to create new shapes by using, for example, in this case, is a milk protein. So it's a whey protein, in fact, alpha-lactalbumin. We are able to produce these nanotubes, and these nanotubes are able to be printable. So we convert a liquid ingredient, a soluble ingredient, such this alpha-lactalbumin, in a printable ingredient that we can have different shapes to offer for elderly to have a more pleasure experience eating. So because for these people sometimes it's really boring eating every day a puree of whatever. So it's a way to how nanotechnology, how we can extract these alpha-lactalbumin molecules to create these nanotubes. By the way, and we have new properties by using these alpha-lactalbumin nanotubes. For example, we can increase the viscoelastic properties, so that means, and thixotropy. So at that stage, so new properties came from this nanoscale, and we can use, for example, this to keep the temperature high, for example, for catering, without melting the product. So this is very interesting to keep the shape of a printed food. This is another example of personalization with nanotechnology. This is not a chocolate biscuit. It's just a biscuit including iron as an ingredient for people that have anemia, that need. So someone eat iron or have treatments of iron for anemia here in. So it's really disgusting, no? So do you have the experience, no? It's disgusting, gastric problems, so it's really bad. But anemia is, again, a problem for elderly and for women as well. So one way to incorporate iron is, in this case in biscuit, is encapsulating iron, again in whey protein, in order to, you can see here how the color disappears. So the shape of the ironed biscuits is more or less the same, and the taste disappears as well. So we are able to mask in these nanoparticles of whey protein iron to make more bioavailable iron, and to have a better experience eating cookies. So another example. Well, fats is another problem. There are a lot of liquid fats, so oils, but there are not so much solid fats, or at least healthy solid fats. So we are able to nanostructure as well with different lipid structuring agents, liquid oils, in order to convert them in solid fats. For example, to replacing palm oil, which is apparently right now a problem, no? Palm oil, no? Everyone want to remove palm oil from the formulation. We developed, for example, that was a master student that did as example that used this kind of oleogels to produce a Nutella without palm oil, That was a really nice experience because was really, really good. So I have not here to offer to test you, but trust me that we are able to produce solid fats with the same technological properties that saturated solid fats, but with a high content of omega-3. Sustainability. Okay, packaging. Packaging is a problem. All of you are aware about this. So this is another example that I'm going to pass very fast by these slides because we're already explained. So you use electrospinning as well technologies, casting technologies, a lot of different technologies in order to produce these coatings or films that allow us to extend the shelf life of, in this case, is a fruit, or pears or apples, or we did as well coatings, special coatings, antifungal coatings for cheese, for example, and using these technologies that were presented already here is able exactly to extend the shelf life and to prevent food losses and wastage. And not only coating, but as well films. For example, this is alginate chitosan films. And keep this in mind because I will come back to this slide, to this film. This is a fully biodegradable film made with two ingredients from wasted, so which is chitosan and alginate from shrimps and seaweeds. But it's just to show. As well, to replace plastic, we propose to use special coatings for paper. Paper is a fantastic material for food packaging, but the problem with paper is paper has very bad mechanical and barrier properties. So, in fact, petrol-based plastics are fantastic. So I like a lot plastics, petrol-based plastics. The problem with plastic is the management that we do with plastics, because at the end, the 80% of the plastic ends in the ocean. This is the problem, but by itself, plastic is a fantastic material. But this is a project that we are developing with a retailer company in order to replace plastic bags for e-commerce. Probably you know that e-commerce is increasing a lot in the last years, and for legal reasons, we have to put in separate bags, for safety reasons, each single product. So one lemon separated from one apple, separated from, so the number of plastic bags that will consume the e-commerce will be really huge. It's fantastic. So one way is to increase the mechanical and the barrier properties of these materials. So we were able to produce super hydrophobic surfaces of paper, and as well to coat with a thermoinsulate layer in order, for example, to use this for fresh products and refrigerated products. Well, this is another example of antimicrobial paper active packaging. So this is microfibrillated cellulose paper covered with one essential oil, so which is cinnamaldehyde, and you can see that we are able to reduce fully reduce the decolonization of two pathogens, which were Listeria and Salmonella, in this antimicrobial paper. Again, like my colleague from Valencia, so smart packaging, we are able to design and to produce this kind of sensors for so here the idea is to replace, to change the mindset. So is to replace the expiration date because probably all of you have this experience to go to the fridge and to take a yogurt that the expiration date is over, but this is good for eating, no? So this is no problem, it's safe, but is not able to commercialize. It's in our house, but sometimes we reject. So this is a lot of food that are rejected. It's a wastage in food. So changing the expiration date for this kind of sensors that inform us about the safety of the food, we can save a lot of foods in the retailer and in the house. Well, as well, we are developing sensors for traceability or safety, sensors based on DNA and microfluidics, but as well by using, for example, magnetic nanoparticles in combination with phages, with virus, that virus are able to recognize specifically pathogen bacteria. So combining all these micro and nanotechnologies, we can develop miniaturized and portable system. One problem right now in the food system is the fraud. So the fraud is related with packaging as well, because how to make packaging that provide to the industrial part a system for anti-counterfeiting. No? This is a problem mainly with the commerce with China, because China, in several products, for example, in high-value products like wine or olive oil or this kind of products, is really a problem. We developed some solutions for anti-counterfeiting. Well, the quality is not very good for the screen, but this is a stamp. It's a fluorescent stamp, so illuminating with a laser, so a normal laser like a pointer. So we can see this watermark, and this watermark was made in. Do you remember the cake, the bread packet in this chitosan alginate film? So this is this film. So we can create this kind of watermarks by the electron beam induced photoluminescence in order to have this watermark to prevent anti-counterfeiting. And as well, we can use a structural color for that. Probably you know that the color of the butterflies is not a chemical color, it's just a physical color that came from this structure, these photonic wheels, these holes, that retain the main part of the wavelengths, and they reflect only the color that we see in the butterfly. So mimicking the nature, we did this pattern, and we are able to produce color, structural color, without chemicals, in, again, this alginate chitosan coating. So a biodegradable, fully biodegradable film that we are able to color or to make this barcode by colors. So putting information in the packaging in order to obtain this information and not anti-fraud information. And this is not chemical. But we can use the same idea to make this pattern for a structural color, for example, to do colored chocolate. This is a colored chocolate with the same pattern, and that relates us with the more green, no additives, so this kind of philosophy that the customer are asking, no, to the industry, no? How to put new properties by using nanotechnology, but here there are not chemicals. It's just the pattern. It's just the pattern in the, and that relates us with emotion. One important thing is how to obtain emotion from food, because food is not just nourish, it's as well to have a emotional relationship with the food. No? And combining all these technologies, we work in, for example, in foams. Foams are really fantastic. So the foam of the coffee, for example, probably you see the advertising of Nespresso, no? With this, do you like beer? So one beer without foam does not make sense. No? Foam is are really fantastic. But the problem of foam is that usually foams are white. How to make colored foams? Okay, we can do Pickering emulsions, so including these dye nanoparticles. So, well, in this case it's a dye, but it could be a vitamin, or it could be whatever. So, and we put these nanoparticles in the borders of the foam in order to stabilize in these Pickering emulsions the foam. So we obtain that allow us to obtain two objectives. First, to stabilize the foam, which is a very important thing. So because when the foam disappears very, very fast is not good, no, for the customers, and have colored foams. For example, we can do blue foams, or with beta-carotene, for example, orange foams. Well, this is a joke. Okay, it could be, but the people is asking for the new experience, to have a blue beverage, a blue beer, colored with, well, whatever. So think about the news, these new rock stars, which are the big chefs, four-star Michelin, that are looking for this sensation. And combining shapes, flavors, 3D printing, structured food, we can do a lot of things combining all these technologies in order to personalize and to have a more pleasant experience. Well, all these examples were made by this group of nano workers that are very passionate scientists at Tailor. Thank you very much.